Here are the homework solutions for section 3-5, the application problems. We're starting on page 101 with number 1. We're asked to use two variables to solve this word problem. So let's read the paragraph and decide what those two variables should represent. 3 times one number equals 1/4 of another number. If the sum of 4 times the first number and 12 equals 3 times the second number, what are the numbers? So I'm going to identify what's actually asked, what are the numbers, and then choose variables to represent them. First number, second number. Let's use x to be the first number and y to be the second number. Now let's reread the sentences and create equations from those clues. 3 times one number, so 3 times x, equals 1/4 another, so 1/4 y. This equation models this first sentence. Let's read the next sentence. The sum of 4 times the first and 12. So 4 times the first plus 12. This is how you show the sum of 4 times a number and 12. And that says equals 3 times the second number. So equals 3y. This model fits the second sentence. We have created a system. Now we need to decide whether the best way to solve the system is by combining things or by using substitution. I'm going to choose substitution because it's pretty easy to solve the first equation for the variable y. We need to multiply both sides by 4. We get 12x equals y. Now we can take that value, 12x, and substitute it in place of the letter y in the other equation. That will create 4x plus 12 equals 3, and then in parentheses we're substituting 12x. Now let's solve this equation. 4x plus 12 equals 3 times 12x is 36x. Now subtract 4x from both sides. 12 equals 32x. And divide by 32. We get 12 divided by 32 is equal to x. This reduces to 3/8. We're halfway done. We know a value for x. Let's take that value and substitute it in place of x so that we can find the y. 12 times 3/8 is equal to y. 12 times 3/8 is 36/8. And this reduces to 9/2. Writing these numbers as an ordered pair, we have 3/8 for our first number and 9/2 for our second number. Now number 3. The measure of one of two complementary angles is 2 degrees less than 3 times that of the other. How large are the angles? I'm going to mark that. That's what we're actually asked to figure out. How large are the angles? Plural. We're looking for 2 of them. So we have our first angle and our second angle. Let's use the letter x to represent the first one and y to represent the second one. Now let's create a system of equations from the clues. The measure of one of two complementary angles is 2 degrees less than 3 times the other. We're told that our angles are complementary. That means if you add them together, it will equal 90 degrees. We're also told that one of the angles is 2 degrees less than 3 times the other. We can write that as angle x is 2 degrees less than 3 times angle y. Now, let's decide the best technique to solve this system. I'm going to use substitution method because in the second equation, the letter x is already solved in terms of the letter y. We can take this expression and substitute it in place of the letter x in the first equation. That will create 3y minus 2 plus y equals 90. 3y plus y is 4y. Now add 2 to both sides and divide by 4. y equals 23. To find x, take the value of 23 and substitute it into our expression for x. We get x equals 3 times 23 minus 2. This is 69 minus 2, which is 67. One of our angles is 67 degrees, and our other angle is 23 degrees. Next, number 5. Tickets for a pre-Broadway showing of a play sold at $4 for the main floor and $2.75 for the balcony. If the receipts from the sale of 1,600 tickets was $5,525, how many tickets were sold at each price? How many of the $4 tickets were sold, and how many of these tickets were sold? Let's identify what we're using variables to represent. The number of the $4 tickets, let's use X for that one, and the number of the $2.75 tickets. Let's use the letter Y to represent that. Now we'll reread the paragraph to create our equations. The receipts from the sale of 1,600 tickets. So the number of the expensive tickets plus the number of the cheaper tickets is 1,600 total tickets. The other thing we are told are the prices for each ticket and the total revenue. So $4 per ticket times the number of $4 tickets plus $2.75 per ticket times the number of those kind of tickets is equal to $5,525. Next, decide which is the best way to solve the system, combination method or substitution method. I'm going to choose combination method and eliminate the x terms. Because this is positive 4x, I would like this to be negative 4x. So let's multiply the first equation by negative 4. Negative 4x minus 4y equals negative 6,400. And keep the second equation the same. Now combine the equations together through adding. The x terms cancel away. Negative 4y plus 2.7y is negative 1.2y. On the right side, when you add these numbers, we get negative 875. Now divide both sides by negative 1.25. Y equals 700. We're halfway done. To find the answer for x, let's substitute 700 in place of y. Which equation looks like the easier one to fill in the 700? The first one or the second one? I think it's the first one. Let's put 700 for y. We get x plus 700 is equal to 1,600. Subtract 700 from both sides and we get x equals 900. So the theater sold 900 of the $4 tickets, and they sold 700 of the $2.75 tickets. Next, number 7. A glass manufacturer makes 2 grades of glass which differ in silica content. If he has 1,800 pounds of silica with which to make one batch of each type, and he uses 216 more pounds of silica for one type than the other, how many pounds of silica were used for each type? Let's call the 2 types type 1 and type 2. We'll use X to represent how much silica is used to make type 1, and Y will represent how much silica is used to make type 2. Let's reread the paragraph to come up with equations. He has 1,800 pounds of silica to make the 2 types of glass. So the silica used for type 1 plus the silica used for type 2 is equal to 1,800 pounds. Another clue is he uses 216 more pounds for one type than the other. So x plus 216 is equal to y. Substitution method is probably the fastest way to solve this because the second equation already has the letter y alone. And we can take this expression and substitute it for the letter y in the first equation. X plus, now fill in that x plus 216, is equal to 1800. This makes 2x plus 216 is equal to 1800. Subtract 216 from both sides. 2x equals 1584. And then divide by 2. X equals 792. Take that answer for x and substitute it for the letter x. We have 792 plus 216 is equal to y. These two numbers add up to 1008. Our first type of glass requires 792 pounds of silica. Our second type of glass requires 1008 pounds of silica. Next, number 21. The original number is a positive integer, and it has 2 digits. Find the integer using the clues. Our 2-digit number will have a tens digit, and it will have a ones digit. For example, the 2-digit number 23 has a tens digit of 2 and a ones digit of 3. Let's use the letter x to represent the tens digit and the letter y to represent the ones digit. Next, let's create algebraic expressions from the clues. The sum of the digits is 6, so x plus y equals 6. When the digits are interchanged, the new number is 3 times the tens digit of the original. If you interchange the tens digit and the ones digit, the number would have the look y and then x. The value of that number would be 10 times the number in the tens digit plus 1 times the number in the ones digit. We're told that that number is equal to 3 times the tens digit of the original, or 3 times x. This second equation can be simplified by subtracting 1x from both sides. This is equal to 10y is equal to 2x. Now let's divide both sides by 2. We get 5y is equal to x. Using substitution method, in place of the letter x, we can fill in 5y. So the first equation would become 5y plus y is equal to 6. Combining like terms, we have 6y equals 6, so y is equal to 1. If y is equal to 1, then 5 times 1 is equal to x. So 5 is equal to x. We have found the original number. Its tens digit is a 5 and its ones digit is a 1, so the number is 51. Number 23. The tens digit is half the units digit. The sum of the original number and the number represented when the digits are interchanged is 99. So we have our tens digit and our ones digit. Or actually, they called it the units digit. Let's use x for this and y for this. What this means is whatever these numbers are for x and y, you're just writing them side by side to create a 2-digit number. Let's read the paragraph again and create equations. The tens digit is, so x is, half the units digit. Now the next sentence. The sum of the original number and the number represented when the digits are interchanged is 99. The original number has a value 10 times the tens digit plus 1 times the units digit. The word sum means to add. The thing we're adding to the original number is the number represented when the digits are interchanged. So the letter y would become the tens digit, and the x would become the units digit. The value of that number is 10 times y plus 1 times x. That is 99. This equation models the second sentence in the paragraph. Let's simplify that second equation by combining like terms. 10x plus 1x is 11x. 1y plus 10y is 11y, and that's equal to 99. In the first equation, let's multiply by 2 to get the letter y alone. 2x is equal to y. Now we can use substitution method. In place of the letter y, we can fill in 2x. So 11x plus 11 times 2x is equal to 99. This makes 11x plus 22x equals 99. 33x equals 99. Therefore, x equals 3. If x is equal to 3, then 2 times 3, which is 6, is equal to y. Our original number has 3 in the tens position and 6 in the units position. The number is 36. For the review assignment, we're asked to solve a system of equations. We're going to do this by deciding whether to use combination method or substitution. For problem 6, combination is the faster way because the y terms are already opposites of each other. Let's add them together. 10x equals 40. Dividing by 10, we get x equals 4. Take that value of x and substitute it into either the first equation or the second equation, whichever one looks like the easier one to use. I think the second equation looks simpler than the first one. So where x is, fill in 4. This makes 8 plus y is equal to 11. Therefore, y equals 3. Our ordered pair is 4, 3. For number 8, I'm going to choose linear combination method. And the variable that I'm going to eliminate is the variable q. I'm going to multiply the top equation by -2. It will become negative 4p minus 2q is equal to -10. Let's keep the second equation the same. Now we'll combine by adding. The p terms are opposites and cancel away. The q terms cancel away, so the left side is 0. -10 add 6 is -4. This is a false statement. What that is telling us is that there are no numbers that can be substituted for p and q that will solve the first equation, and at the same time, they'll solve the second equation. There's a vocab word that you put for this. It has no points of intersection between the lines. Number 14. We're not used to seeing systems of equations where the constant term is on the left side along with the variable terms. Let's rewrite this just to make it look like one we're comfortable with. Now let's decide whether to use substitution or linear combination method. I'm going to use linear combination method, and I want to eliminate the s terms. The least common multiple of 2 and 3 is 6. Let's make one of the s terms be positive 6s and the other s term be negative 6s. For the top equation, times by 3, we'll get 6s minus 9t is equal to 3. For the second equation, times by -2, we will get negative 6s plus 8t is equal to -14. The reason we multiplied by these two values was so that the s terms would be opposites. Now when we combine, the s term cancels away. -9t plus 8t is -1t. 3 plus -14 is -11. Therefore, t is equal to 11. Take that answer for t and substitute it into either one of these equations. I'm going to put it right there. we get 2s minus 3 times 11 is equal to 1. 2s minus 33 is equal to 1. Add 33 to both sides. 2s equals 34. And divide by 2. S equals 17. In alphabetical order, S comes before T. So the answer is 17, 11. For page 94, we're asked to graph and then create an equation for the information given to us. For problem 2, we're told that there's a line that goes through the point 3, 4, and the line's slope is -2. We are given a point and the slope. From that, we can make the graph. 1, 2, 3, 1, 2, 3, 4. Here's the point 3, 4. Let's interpret our slope as a ratio, -2 over 1. The top number is rise, the bottom number is run. Because the rise is a negative number, we're really going to move downward. I'm going to put one more mark on there so I can run to the right one spot. From this dot, go down 2 units and right 1 unit. Then draw a line through the dots. Now we're asked to create an equation. We are given a point and a slope, so we're going to use point-slope form. The formula is y minus y1 equals m times x minus x1. For y1, fill in 4. For m, fill in -2. For x1, fill in 3. This is an equation, but it's not in the form ax plus by equals c. Let's do the distributive property. -2 times x is -2x. -2 times -3 is +6. Next, add 2x to both sides. Then add 4 to both sides. This equation has the format ax plus by equals c. Number 14, same directions. We're going to graph and then create the equation. To graph a line, when you're given 2 points on the line, locate the 2 points. 1, 2, 1, 2, 3, 4, 5. Here's 2, 5. 2 more marks over will get us to 4, and 2 marks higher will get us to 7. Here's 4, 7. And draw a line through the dots. Now let's create an equation. To make an equation, you must know the slope. We're not given the slope, but we can find it with the slope formula. M equals y2 minus y1 over x2 minus x1. These numbers are the x1, y1, and the x2 and y2. So y2 is 7, and y1 is 5. x2 is 4, and x1 is 2. This makes 2 over 2, which is equal to 1. Now we can use point-slope form. Y minus y1, that's a 5, equals the m, so fill in the 1 we figured out, and then x minus x1, that's a 2. Now let's change this to the ax plus by equals c form. On the right side, multiplying this by 1 just creates the x minus 2. Now let's subtract y from both sides. We get -5 equals x minus 2 minus y. Now add 2 to both sides. -5 plus 2 is -3. And that equals x minus y. If we use the symmetric property, we can make this look like ax plus by equals c. Number 26. Write an equation for a line with a y-intercept of -4, and it is parallel to this line. Parallel lines have the same slope. Let's figure out the slope of this one. Subtract x from both sides. Y equals -x plus 5. This is slope-intercept form, and the coefficient of x is the slope. So the slope is -1. We want to create an equation for a line with a slope of -1 and a y-intercept of -4. We know the slope and we know the y-intercept. It makes sense to use slope-intercept form. The formula for that is y equals mx plus b. We know the value of m, it's -1. And we know the value of b, the y-intercept, it's -4. Here's our equation. Now page 80, number 2. We're given a word problem. The sum of an integer and half of another integer is 15. Find two pairs of integers. For the first number, let's use x. For the second number, let's use y. Now let's reread the sentence and create a model. The word sum means to add. We're supposed to add the first integer plus half of the other integer, and we're told that that is 15. Find two pairs of integers. So find two roots to this, or two solutions to this. We could use an xy table to help us organize. If the letter x was 0, we would have 0 plus 1/2 y is equal to 15, which means y is equal to 30. So one pair of integers that works is 0 and 30. Let's choose another number for x. Maybe x is 10. 10 plus 1/2 y is equal to 15. Subtracting 10 from both sides, we get 1/2 y is equal to 5. That means that y is equal to 10. So another pair of integers is 10 and 10. We could find many others that work, but we were only asked for two pairs. Number 10, an isosceles triangle has a perimeter of 14 feet. Give all integral choices for its side lengths. An isosceles triangle has two equal length sides. I marked those sides with these little tick marks. If this side is x, then so is this side, because they're equal to each other. The other side of the triangle, we could use y. When we add up around the outside, we get 14. So x plus y is equal to 14, or 2x plus y is equal to 14. Let's find all of the possibilities that are integers. X cannot be a negative number because triangles cannot have negative length sides. X cannot be 0 because triangles can't have sides that are 0 in length. So the first reasonable number to even try for x is a 1. Let's organize our work in a chart. If x was 1, then y would be 12, because 2 times 1 plus 12 is 14. What if x was 2? 2 times 2 is 4, so y would have to be 10. What if x was 3? 2 times 3 is 6, so y would have to be 8. What if x was 4? 2 times 4 is 8, so y would have to be 6. What if x was 5? 2 times 5 is 10, and so y is 4. What if x was 6? 2 times 6 is 12, so y is 2. What if x was 7? 2 times 7 is already 14, so y would be 0. But y cannot be 0 because a triangle can't have a side that is 0 in length. Let's cross off this last row. Our table shows all the possible side lengths for the triangle. For every one of these numbers, you would just want to write down the unit feet every time. On page 79, number 14, we're given an inequality and asked to find three roots. Let's solve for y by subtracting 3x from both sides. And make a two-column table to help us organize our roots. We're told to use real numbers for the domain, so one real number that's easy to use is 0. Filling in 0, this makes y is greater than or equal to 5 minus 3 times 0, which is the same thing as y is greater than or equal to 5. From this one row, we've actually found an infinite number of roots. When x is 0, y could be 5. When x is 0, y could be 6. And when x is 0, y could be 7. There are many other roots where x is 0, along with all kinds of roots where x is another number not 0. Now number 18. We could rearrange the form of this or leave it like it is and use guess and check strategy to find answers that work for x and y. Let's organize in a chart. If x was 2, our expression would be the absolute value of 2 minus the absolute value of y is equal to 2. The absolute value of 2 is 2. What does this have to turn out to be to make a true statement? This has to turn out to be 0 because 2 minus 0 equals 2. The only way for this expression to be 0 is if y is equal to 0. So when x is 2, y is 0. Let's try another number for x. Let's try negative 2. Our expression would look like this. The absolute value of negative 2 is 2. We get the same result as we had before, so we know that y must be 0. So another solution is negative 2, 0. Let's substitute another value into the original expression. Maybe x is 4. The absolute value of 4 is 4. What does this expression have to be to create a true statement? This has to turn out to be 2, because 4 minus 2 would equal 2. So we know that the absolute value of y must be 2. Now ask, what could y be? Y could be 2 or negative 2. So we found some more roots. When x is 4, the value of y could be 2. Or when x is 4, the value of y could be negative 2. We only had to find 3 roots, and we actually found 4 of them.